page 9, number 41. Find each of the missing values from A through E. Okay, we're going to be looking at our special angle relationships as we go through this. I'm going to zoom in, and we're going to take it step by step. Now, there may be some things that I go over that you didn't notice, and you found your own ways of getting A, B, C, D, or E, and that's completely fine. As long as you got the same answer that we did, there's many approaches to getting all of these letters. All right, let's get started. One of the first things that I notice is I see a right angle that combines the 50 and the E. So a right angle is 90 degrees. So to get E, I'm going to do 90 minus 50. And we see there's 40 degrees left over for angle E. So I have E. Next, I also notice that that 50 degrees forms a linear pair with A. A linear pair makes a straight line, and they add up to 180, the two angles. So I'm going to do 180 minus 50 to see what's left over for angle A, which is 130. So angle A is 130 degrees. All right, let's keep it moving. I also see some vertical angles. So I see that this 50 degrees is vertical to angle B. So if I have vertical angles, then those are congruent. So I'm going to put in 50 degrees for angle B. Now, the next thing that I'm going to look at is, well, I see another right angle. I see D and E together forming a right angle. Well, if I already know angle E, then angle D should complete the 90. 40 and angle D make 90. So that means that angle D is 50. Again, because I do 90 minus 40, which leaves me with 50 degrees for angle D. So this angle D and this angle 50 are congruent because they both need angle E to complete 90 degrees. Next, our last letter, C. There's a couple of different ways of getting it. One thing that I notice is that if I have a right angle formed by D and E together, then with this line, I need to also have a right angle formed on the other side of this ray. So I should also have a right angle formed by B and C because D and E make up 90. So there should also be a 90 on the other side to complete the straight line. So again, if B and C add up to 90 and I've used up 50 degrees for angle B, that means that I have 40 degrees left for angle C. And that's all of them. So make sure to put all of these answers into your answer section. Number 42. Find the value of S. Okay, I see parallel lines cut by a transversal. So you should be thinking about alternate interior angles, alternate exterior angles, corresponding angles, same side interior, all of those good things. I like to always rely on that Zaro Z that I had mentioned before. So if I look at where the S is, I'm going to create a Z that traps that S in the corner. So this angle S is going to be congruent to whatever the measurement is for this angle down here. Because remember, the corners of your Z are congruent. So I noticed that this angle that I just highlighted in blue is forming a linear pair with the 115 degrees. So I know that I can get that missing angle by subtracting 115 from 180. 180 minus 115 leaves me with 65 degrees. So 65 is the measurement right here, which means according to our Zaro Z, angle S is also 65 degrees. Now, Zaro Z is not a really technical name. What these two angles are, the 65 and angle S, those are called alternate interior angles. And the alternate interior angle theorem tells us that if you know your lines are parallel, which we do, they gave us these symbols, then that means that the angles that fall in the alternate interior angle section are going to be congruent. Okay, let's move on. Number 43. Choose the best answer from the choices below. Okay, the value of x is 12 because yada, yada, yada. Okay, so it seems like we need to figure out what x is. Now, take a look at your diagram. Again, you have parallel lines cut by this transversal. The angles 4x plus 9 and the 6x minus 15 are congruent. The reason they're congruent is because they're corresponding angles. They're in matching positions. Corresponding means matching. Now, looking at your answer choices, there's only one that talks about corresponding angles. Now, let's make sure we're correct and that we do get a value of x as 12 by applying the corresponding angles postulate. Now, the corresponding angles postulate says that the angles that are corresponding when your lines are parallel are going to be congruent. So we can set their measurements equal. So 6x minus 15 is equal to 4x plus 9. I'm going to subtract the 4x first to bring the x's all over to one side. 2x minus 15 equals 9. Next, I'm going to add 15 to both sides. So I have 2x equals 24. Divide both sides by 2. X is 12. Perfect. That's exactly what we wanted. Choice C. All of our other answer choices are either incorrect because of their value of x, just like choice B and choice D, or in choice A, it says the value of x is 12, which is correct, but the angles are not alternate interior angles. So that's not the reason for why we set those two angle measurements equal. We set them equal because they're corresponding angles. Okay, let's move on. Number 44. Triangle DAF has coordinates of D, A, and F as listed. Find the perimeter of the triangle to the nearest tenth. Our goal is to get perimeter. Very straightforward. Now, to get perimeter, you have to add up all the side lengths that make up your shape. Let's take a look at what our shape looks like. So we're going to take a minute. We're going to plot. So D is at 3, 2. A is at negative 5, 6. And then F is at negative 2, negative 6. Okay. I'm going to label these D, A, and F. And I'm going to connect them with a straight line. Okay, so if we want to find the perimeter, we need to add together all three side lengths. So you should have 1, 2, 3 side lengths ready to go. One of the sides will be AD. The next one could be DF. And the last one will be AF. So remember, to get perimeter on a graph, the best way to do it is to ignore the distance formula and go for Pythagorean theorem. So to get each side length here, I'm going to create a right triangle with each of the missing side lengths that I'm looking for. So this would be the triangle I would use to find AD. This is the triangle I would use to solve for DF. And then lastly, this is the right triangle I would use to solve for AF. Go ahead, count up all the different side lengths, and start doing your Pythagorean theorem. So for AD, I have lengths of 8 and 4. For DF, I have lengths of 5 and 8. And lastly, for AF, I have lengths of 12 and 3. We're going to go one at a time. So starting with AD. I'm going to do 8 squared plus 4 squared equals, and I'm going to be fancy and write AD squared. 8 squared is 64. 4 squared is 16 equals AD squared. 64 plus 16 is 80. Take the square root, and that's going to leave me with the length of AD. Square root of 80. Let's keep chugging along. The next one that I'm going to do is DF. So for DF, I have lengths of 8 and 5. So it's going to be 8 squared plus 5 squared equals DF squared. 64 plus 25 equals DF squared. 64 plus 25 is 89. We'll square root that at the end, and it leaves us with DF. And then lastly, I need AF. I'm going to give myself a little bit more room to write. So now we have AF. 12 squared plus 3 squared equals AF squared. 144 plus 9 equals AF squared. 144 plus 9 is 153. We square root at the end, and that leaves us with AF. Okay, I'm going to go ahead and put the square root of 153. And now we're ready to add all these together. Now remember, the reason I didn't put them into my calculator individually is because I didn't want to round too early. So now I'm going to put all of these in with their square roots into the calculator. So I'm going to take the square root of 80, which is approximately 8.9. To that, I'm going to add the square root of 89. I type 89, then I hit the square root. The square root of 89 is approximately 9.4. Okay, hit equals to add them together. And then lastly, the square root of 153 plus 153 square root. So it's approximately 12.4. Yes, go ahead and add it. And so now our final answer is on the screen. Without rounding, that's our final answer. However, when we write it on our paper, we have to round. And they told us to round to the nearest tenth. So our final answer is going to be 30.7 units. Not units squared. Perimeter is just the length, a length all the way around the outline of your shape. That completes page 9. Let's keep it moving.